Hello everyone, my name is Arman Heidari and I'm a graduate with a Bachelor of Science in Computer Engineering from Shahid Beheshti University. Today I want to present a paper I co-authored with my professor, Dr. Mehran Alidoost. I'm sincerely grateful for his guidance and support. In this paper, we introduce a framework called JetCert. JetCert is a self-adaptive compilation framework for fast and safe code execution, which is also the title of our paper. Let me begin by introducing the capabilities of the JetCert framework. JetCert designed for embedded and safety critical system, and it focused on establishing an optimal trade-off between safety guarantees and system performance in embedded and safety critical systems. JetCert has a MAPE control loop that can monitor system states at defined intervals to maintain system objectives, and MAPE stands for monitor, analyze, plan, execute, and knowledge. Besides, JetCert has a priority-based CI/CD pipelines for dynamic change management in embedded and safety critical systems. My motivation for designing this framework is first absence of a critical strategy for modern embedded and safety critical systems, second, development of a practical framework to address a fundamental software challenge, and finally my long-standing passion for the intersection of software and security. I'm very interested in these two areas. So the main problem is that we have an embedded or safety critical system with set of requirements called R. Each requirement has M versions denoted by V, and each version is just either safe or fast. We want to select the best version from V for every requirement in each period of the MAPE loop, in which the total utility of the safety critical system is maximized. Before looking at the architecture of JetCert, let's review the necessary background. First, the concept of self-adaptive systems. Self-adaptive systems are computing systems with built-in capabilities to automatically adjust their behavior when their operating environment changes. These systems track their state and environment, detect significant change, and respond autonomously to meet objectives. The core defining characteristic of self-adaptive systems exist in their closed feedback loop known as the MAPE control loop. The adaptation process follows explicit adaptation goals and policies and constraints. For the second, certified compilation represents a strict compiler method requiring formal proofs to ensure compiled code preserves program semantics and generates mathematical certificates that prove compiled code behaves identically to source code. The method proves essential for safety critical system by ensuring the highest possible confidence level, and for example, ComCert is a certified compiler that we used in JetCert, and J8 compilation combines interpolation and static compilation features. Through dual execution, the code first gets interpreted, then detects hotspots to enable dynamic compilation and stores it for future use. The system performs optimization based on runtime profiling data collected during execution to guide optimization decisions. And for example, Numba is a J8 compiler that we used in JetCert. So it's time to examine the architecture of JetCert. Developers of safety critical systems to design and implement their systems within the JetCert framework must first divide the system requirements into two distinct categories. The first includes requirements that need the establishment of an optimal trade-off between safety, system safety and performance. We designate these requirements as the self-adaptive requirements because they need to adaptively shift between two different compilation paths. The second includes requirements that utilize a fixed compiler path. We refer to these requirements as the other requirements. JetCert manage and adaptively executes self-adaptive requirements according to changing specification in the environments, while other requirements proceed through their native runtime paths independent of JetCert control loop. To use JetCert, developers should implement self-adaptive requirements in modules structure and provide them as input to the JetCert framework. Modules is a structure in which developers of the embedded application implement each self-adaptive requirement in the form of a module structure. Additionally, developers of safety critical systems define the shift conditions between different versions of each module using the MAPK rules structure, which will be discussed later. And module is a structure in which developers of the embedded application can implement several versions to satisfy self-adaptive requirements. At runtime, JetCert adaptively shifts between different versions of each module based on the captured change in the environment. The core is the central part of JetCert that is responsible for managing and maintaining the modules structure. The core consists of two components named modules management and versions management. The modules management stores the state of each module and runs version of each module in the current period. The modules management part provides adaptive runtime capability to developers, allowing them to respond to user requirements based on the current situation. Adaptive runtime is an interface that adaptively responds to requests. The versions management records the state of each version and determines how each version should be compiled and executed based on its configuration file. If needed, other JetCert components can request version management to compile or execute a version. JetCert, by implementing the MAPK loop subsystem, monitors the system and the environment in each period. The MAPK loop can adaptively change the state of each module in the modules management components based on the MAPK rules and rules defined by the developers in the MAPK rules. The adaptive runtime components is update and shifts to execute the best version of each module. MAPK rules is structures defined by developers of the embedded application that enables JetCert to shift between different versions of each module according to the rules. JetCert facilitates change management by implementing CI/CD pipelines and enables the update process of change for the safety critical systems. JetCert prioritizes change made by developers and ensure that JetCert deploys a higher priority update first. JetCert make it possible to continuously make change over different versions of each module. JetCert creates a priority queue to organize the modified versions, placing each modified version in the priority queue according to a priority level. Finally, Builder is a library in JetCert that performs operating system and infrastructure operation with a high level of abstraction for other JetCert subsystems. Builder has various functions that handle different OS and infrastructure requirements. The Builder subsystem consists of three main components named Safe Builder, Fast Builder, and a CI/CD Builder. As an example, we implemented an safety critical system with JetCert, and we will see its experiment. This system has 4 self-adaptive requirements: user login, cryptography, finance, and physics. As a result, we implemented 4 modules in these systems, each with different versions with unique features. User login module, finance module, cryptography module, and physics module with different versions. For experiments, these graphs show JetCert adaptively to potential attack for 2 modules and in 3 periods, and each period is 16 seconds. When the probability of attacks increase within MAPK period and greater than threshold defined by developers of safety critical systems, JetCert automatically shifts to a more secure version of the module and returns to a faster version when the potential threat is eliminated. These graphs show the time it takes to monitor the environment and decide on the best version for each module. First chart is the process time of MAPK control loop in 100 period, and the second chart is the time to adopt of these 100 periods. So these diagrams show the process of making changes to the Git and their priority update based on time. The first chart is the number of changed version, modified version over time. The second chart is the processing time and adding to the queue in order of priority based on time. And the third chart is the update chart of modified versions based on time. Finally, this diagram shows all the embedded system pipelines that we implemented with JetCert and shows the shift between different versions of each module under different conditions. The first pipeline is for MAPE and MAPK, and the next pipelines are for modules and CI/CD pipelines. For conclusion and future direction, JetCert is a novel self-adaptive compilation framework designed for embedded and safety critical systems. It can balancing safety and performance at runtime. It can robust adaptively in resource constrained environments, and it has prioritized the CI/CD pipeline. And in future, we want to translate of Python subset to ComCert compatible C code and add RL for update priority decision making in CI/CD pipelines, and we want to have better builders in our framework. So our project is available in Zenodo, and you can clone it. And thank you for your attention.